So Tim, first off, when I see this as an 11,000 watt generator, what does that really mean? What are the specs I need to know?
Well, 11,000 watts is what it will withstand a surge of power draw.
Yep.
Actually, the running power is generally 2,000 to 3,000 watts less
Gotcha.
than the rated.
So this model on gasoline is actually 9,000 watts running, and pretty close to that on propane too?
Right. I think propane has a higher capacity of output than natural gas does. The gasoline probably even has a higher than that.
Yeah. But then this one has a really cool trick. It'll run on gasoline, on propane, or
natural gas.
yeah, that's pretty awesome.
Yeah.
Especially in a situation like this where we're thinking about, hey, when the storm comes, how do we power my house? Now, this particular model has a couple features I like. First off, a really big, like 6-gallon gas tank. So at 25% load, I believe, Tim, this will run about 15 hours.
That sounds about right.
So well overnight, assuming it's not running at full speed, right? 25% load.
Right.
But if I were to hook this up to a natural gas line, I could run it, in perpetuity, supposedly, right?
Right. As long as you have natural gas at your house, it'll run.
That's pretty awesome. Now tell me about the plug situation here, because Tim and I both have RVs. We have job site needs for a unit like this. So let's talk about how we could use this first off on a backup for your house.
Most high capacity generators have multiple plugs on the interface.
Yep.
Generally, the highest capacity of all those plugs will be a 50 amp NEMA rated plug.
Okay.
However, most generators don't set it up on a 50 amp circuit. They're
Gotcha.
generally a 35 to 38 amp circuit
Got it.
on a 50 amp NEMA receptacle.
And that's what this one is here on
That's
the 50
right.
amp.
That's its highest capacity interface.
Yep.
It also steps down to a 220 volt 30 amp interface, a twist lock, and that's what you would normally use for most smaller 2-pole applications.
And that's what you've got at your house here.
That's
so
right.
This one is the plug-in for your inlet in your house. And so this 30 amp plug you're going to use for your 120 circuits on your house, right?
That's right. That's right. In most residential environments, 30 amps is a lot.
Mm-hmm.
Unless you're running air conditioning equipment or electric ovens or electric cooktops, most 110 circuits for lighting or for plugs or fans, that's generally enough, especially during nighttime when you need backup power the most.
Yeah, makes sense.
Yeah.
Now you and I both have Lance campers that take a 30 amp 120, and this doesn't have an actual plug for 30 amp 120. Could we use this to run our Lances?
Sure you can. You'd need an adapter like this one that would convert the NEMA 50 to a 30 amp plug-in RV plug.
So help me understand what these different poles do on a 50 amp 220 type plug-in like we've got here.
Well, the 50 amp, what we in our residential industry call a range plug, used for electric ranges, has 4 prongs. One is ground, one is neutral, and then there are 2 hots.
Okay.
The 2 hots always make up a 240 circuit.
Gotcha.
Right? And so it would convert it to a 110, which would be the ground, a neutral, and a hot, by just connecting to one of the hot sides.
Gotcha.
Right. And so we don't know what's going on internally, but one of these, the hot, is connected to either this one or this one.
So in other words, we could still plug this into our 30 amp 120 camper plug
Right.
to power our camper.
Right.